Alex Vert. That's a lot of pluses. Alright. Well, alright. I should get started, I guess. Hopefully Ryan will make it over. Okay. 15 minutes and 5, 4, 3, 2, 1. Okay then. Okay. Listing with list. Oh, let me fix that. Alright. Right now, we're not really worried about dancing time because dancing time today is done for the day. So in the improv, those both are good to not be around, and that one too. Okay, great. Okay, continuing on. Hey, Brown Precaution here. Well, I don't. Okay, that's the one I'm looking for. All right. Well, let me try that again. 15 minutes and 5, 4, 3, 2, 1. Okay. Listing with list. Hi, good evening, and good day. I hope you're doing well. Thank you for the welcome and the like. Listing with list. A list is a simple container similar to an array, except you can't access the members. Oh, good. I'm glad you're doing good. My day went well. That's a nice thing. It's always a great time when my job goes well. A list is a simple container similar to an array, except you can't access the members of a list by using a bracket notation as you can in vector or with an array. You don't use list when you only need to access one item in the list. You use it when you plan to traverse through the list, item by item. To add items to a list, use the list push underscore front member function or its push underscore back member function. The push underscore front function inserts the item in the beginning of the list in front of all the others that are present in the list. If you use push underscore front several times in a row, the items will be in the reverse order from which you put them in. The push underscore back function adds the item to the end of the list. So if you put items in a list by using push underscore back, their order will be the same as the order in which you add them. Oh, thank you for precautionary for suggesting people to subscribe and to like. You can also insert an item before an existing item if you've placed a pointer to the item inside the list. Remember, for operations where you need a pointer, to an item in the list, you need to use an iterator. An iterator is simply a typed up for a pointer to an item in the list. However, it points to the item in the list, not the original item you added to the list. Remember, the containers hold copies. Thus, if you do an insert into a list and point to the original item, that item won't be a member of the list, and the insert would work. Tip: although the list template includes an insert function, this function has only very special uses. To use insert, you must have a pointer to an item in the list. That is, you need to have an iterator. How do you get to this pointer? By traversing the list. It has no find function, and so really the only time you would use the insert function is if you're already working your way through the list. But if you do need to do an insert and you're willing to use iterators to move through the list to find the location where you want to put the new item, insert will do the job. The list example shows in listing 6-9 demonstrations, shown in 6-9 demonstrates lists by using a duck metaphor. They're all in a row. In this example, we create a list, add our ducks to it, and then reverse it. Next, we create a second list and splice its members into the first list. Listing 6-9, handling items in a list template. Hashtag include iostream, hashtag include list. Using interface standard, class duck, public string name, int weight, int length, ostream ampersand operator, ostream ampersand out, const duck ampersand duck, C out, parentheses, duck.name, C out, comma, duck.weight, C out, duck.length, C out, right parentheses, return out. Void dump ducks, list duck, star my list, list duck, iterator iter equals my list, get begin, while iter does not equal my list, end. Listing 6-9 continued, C out, start iter, inline, iter, plus plus, list duck, iterator, move to position, list duck, my list, and pause, list duck, iterator rest equals my list, get begin, for int loop equals 1, as long as the loop is less than or equal to post, loop plus plus, rest plus plus, return rest. Int main. Huh? Oh, hi, Lansford. Yeah, I'm live. Int main list duck. Or how are you doing? Push sum at the beginning. Duck D1 equals gem 2015 versus notation. In arrow dot push underscore front, D1. Duck, D2 equals, in a row, Duck, D2 equals Sally 1512. In a row, dot push, underscore front, D2. Push some at the end. Duck, D3 equals Squeaky 1825. In a row, dot push, underscore front, D3. Duck, D4 equals Trumpeter 1926. In a row, dot push, front, D4. Duck D5 equals Sneaky 1213. In a row, dot push, underscore front, D5. Display the ducks. See out. A lot of equal signs. In line, dump ducks. Ampersand, in a row, reverse. In a row, dot reverse, see out, bunch of equal signs. In line, dump ducks. Ampersand, in a row. Splice, need another list for this. List duck, extras. Duck, D6 equals grumpy. 8, extras dot push back, D6. Duck, D7 equals sleepy. 8, extras dot push back, D7. Duck D8 equals ornery. 8, extras dot push underscore back, D8. Duck D9 equals goofy. 8, extras dot push underscore back, D9. See out, a lot of equal signs in line. See out, extras in line. Dump ducks. Ampersand, extras. List, duck, colon, iterator, first. No, gosh, it's cool. I was saying I was going to go do this stream. I was saying goodnight to anyone who didn't feel like making it over to this stream. List duck, colon, iterator first. Move to position. Hold on. Let me go back to just under goofy. See out. Bunch of equal signs in line. See out, extras. In line, dump ducks, ampersand extras. List duck, colon, iterator first, equals move to position, ampersand extras, comma, 1. List duck, colon, iterator last equals move to position, ampersand extras, comma, 3. List duck, colon, iterator into equals move to position, ampersand in a row, comma, 2. In a row dot splice. Into, comma, extras, comma, first, comma, last. See out, lot of equal signs, in line. See out, extras, after splice, in line. Dump ducks, ampersand extras. See out, bunch of equal signs, in line. See out, in a row, after splice, in line. Dump ducks, ampersand in a row. Alright, that took a while. How much time do I have left? Okay, we made, just under 4 minutes, we made a function, move to position, that moves to position in the list. This may seem counterproductive because the list template doesn't allow random access, but we needed 3 iterators to perform this splice. 2 to target the start and in position of the second list, the one we're splicing members from, and 1 to target the position in the first list where we want to put the spliced members. For that last bit of business, we needed the 3rd iterator, which move to position finds for us. Remember, the function we created, move to position, is a template function, but when we called the function, we didn't provide the type name in angle brackets. The compiler can figure out which class version we need. The compiler knows that it can look at what we passed into the function as a parameter and use its type to decide the template parameter. Without the template type in the function parameter, the compiler can't figure it out. Here's the application output. Sneaky 1213, Trumpeter 1926, Squeaky 1825, Sally 1512, Jim 2015. I shall those parts that I don't want to necessarily say a little bit too because it takes too long. Jim 2015, Sally 1512, Squeaky 1825, Trumpeter 1926, Sneaky 1213. Extras, Grumpy 88, Sleepy 88, Ornery 88, Goofy 88. Extras, After Spice, Grumpy 88, Goofy 88. In a row, After Spice, Jem 2015, Sally 1512, Sleepy 88, Ornery 88, Squeaky 1825, Trumpeter 1926, Sneaky 1213. You can see the elements that were inside the two lists before and after the spice. The ducks moved from one list to another. When you specify the position, remember, when you specify the positions for the splice operation, the splice includes the start position up to but not including the ending position. Listing success line shows this. A spliced from position 1 to 3 in the second list, extras, but we got the ducks from positions 1 and 2 because the code spliced position 1 up 2 but not including 3, which is 2. Showdown, lists versus vectors. With the list, you do not have any random access to list, which is a fancy schmancy way of saying that you can't drop into the middle of the list and look at whatever item is stored there, as you can with the vector. If you want to look at the items in the list, you must either start at the beginning or the end and work your way through it one by one. But with a vector, you can refer to any element by using brackets, as in my vector 3. This may seem like a disadvantage for the list, but the ANSI document claims that many algorithms only need sequential access anyway. We suppose that there are times when you don't need to drop into the middle of an array, and then a list might do. But lists have different advantages. The list template allows you to splice together multiple lists, and it has good support for sorting the list, for splicing members out of one list and into another, and for merging multiple lists. Alright, that's gonna be it. My timer did go off, and I did just finish that section I was working on. So that is going to be it for reading time for today. Looking forward to more reading time tomorrow. Alright, let's set a timer. I'm just kind of talking to myself at this point. Let's say 2 minutes. 2 minutes and 5, 4, 3, 2, 1. So I'm sitting here and I'm getting tired. So I think I'll hold off on Kingdom Hearts stream until tomorrow or some other time over the weekend. Because I kind of just want to go sleep and be ready to help my boyfriend. Oh, hi Jennifer. Oh, that's super kind of you to say. It's good to see you. I was dancing earlier, but I'm just doing a C++ All-In-One For Dummies stream. And then that's gonna pretty much do it for tonight. I'm getting sleepy. How are you doing? Oh, you just finished work. That's great. Sorry, I'm on my way out. That's the thing about weekdays. Although I'll be sleeping in a bit tomorrow, it's still pretty much like a wake up at 4:30 instead of 3:15 sort of thing. But usually on weekdays, I'm waking up 3:15. So that's what I did today, and I am feeling it. Oh, okay. Well, thank you, Terrifier. That's great. But yeah, I'm looking forward to the weekend. Tomorrow will be Friday signing off again. And then I look forward to doing some more C++ on for dummies. And hopefully some Kingdom Hearts streaming time. And then Saturday dance break, Sunday dance break. Um, we'll see how that goes. With C++ on for dummies time, etc. All right, that is definitely time. All right, thank you, Terrifier. Please also have a great night. Yeah, I'm gonna go ahead and get ready to go to bedtime. Sounds like a winner. Good night, Terrifier. Good night, Nightbot. Good night, Leon Swerve. That is so cool that you were able to make it to stream. It has been a bit. Good night, Lexi Bear, who probably has a. Oh, you're right back. Oh, yo, hey. All right. Good night, Lexi Bear. But yeah, that's gonna be it for me tonight. I'm gonna get some sleepy times. So please enjoy your evening. I'll check in with you guys tomorrow for Friday signing off, and hopefully some more C++ on for dummies, and hopefully finally get that Kingdom Hearts stream going. Nice, that'd be great. I ran a little test last night, and I understand why things did not save. Thankfully, I didn't go through a full stream and then have it not save. That would have been pretty messed up. I would have been very not happy about that. Anyway, looking forward to soon. Hopefully, Kingdom Hearts time. I just love that game series just so much. So, and some of you guys don't know what I'm talking about, and some totally know what I'm talking about, and also love the game. And either way, it should be a fun time. All right, well, thank you kindly. Again, enjoy your evenings. Get some great rest. Do that self-care that you gotta do. I will do the same. And yeah, till tomorrow then. So for anyone who is here now or will maybe checking that out in the future, just whenever, whatever, just make the best of it. That's the most important. The most important part. Bye bye.